Okay, so this is the angle bisector notes. Angle bisector theorem states if a point is on a bisector of an angle, then the point is equidistant from the sides of the angle. So what that means is if I have point D here and is on the bisector of angle BAC, and the bisector is AD, point D is equidistant from line AB to line AC. You can see that this line, only if you create perpendicular lines, this line is equal to each other. So like the statement here, if AD bisects BAC and AB is perpendicular to BD, so this line is perpendicular to that one, and AC perpendicular to DC, then BD is congruent to DC. Okay, the converse angle bisector theorem. If a point is on the interior of the angle and equidistant from the sides of the angle, then the point is on the angle bisector. So if BD and CD are congruent and AB is perpendicular to BD and AC is perpendicular to DC, then AD bisects BAC. So we're going to use this to solve for sides on triangles. Okay, find the value of x. So I have an angle bisector like I do in this picture up here, and I have perpendicular lines. So I know, like it shows up here, these two sides will be congruent. So I can set these equal to each other. 4x plus 30 equals 9x minus 5. I can solve for x. Subtract 4x on both sides. 5x minus 5 equals 30. Add 5 to both sides. 5x equals 35. Divide by 5 on both sides. X is 7. Now, this is going back to the converse. So you can see that this replica matches the angle bisector theorem. So we know this is a bisector. We know this is a bisector because of the angle marks. We're told that the angles are the same. That makes this an angle bisector. Also, we are told that they are perpendicular. That's how we know these two are equal to each other. We could set them equal. So this is kind of leaning towards the bisects part, the converse of the angle bisector theorem. We are told that these two sides are congruent, like it says here, if these are perpendicular, like these two statements, then we can find out that these two angles are equal to each other. So we could set them equal to each other. 5x minus 11 equals 8x minus 41. We're going to solve for x. So I'm subtracting 5x on both sides. I'm also going to add 41 to both sides, so I get this side all by itself with the x's. Divide by 3 on both sides. X equals 10. Alright, now we're going to take it a step further, and we're going to solve for entire sides and angles, not just x. So this kind of looks similar to the one up here. So we are using the angle bisector theorem. We have an angle bisector because this line bisects the entire angle, creating two congruent angles. And we have perpendicular lines on the opposite side. So I know these two equations, these two segments will be equal to each other. 13x minus 4 equals 8x plus 11. Solve for x. Add 4 to both sides.
Good.
5x
Huh?
equals 15. Divide by 5, divide by 5. X equals 3.
Are you talking?
Yeah, I'm talking.
You're talking into there?
Yeah, it's recording my voice.
Awesome. Mr. Yeager's awesome.
What's up?
This stuff's pretty intensive. I did like the odds in class. And then-
Yeah, I'm. They'll see in this. I'm like doing opposite, so they're gonna go back later when we're studying to do the ones I didn't do.
Yeah. Yeah, we did the odds. And then now I did look at the test, and me and Bubner talked like for in centers and circumstances.